Okay, so let's graph y equals -3 sine 1/2 x minus pi over 4, quantity plus 1. So if you are watching the video, please pause when I say take whatever amount of time, and then unpause in that amount of time, and we'll catch you back up to make sure you're on the right track. Okay, so first thing we're going to do is always put it in general form, which means we have to identify b, which is 1/2, and we have to factor it out of the argument here. So when we do that, we end up with y equals -3 sine of 1/2 x minus pi over 2, all plus 1. This tells us that a is -3. So go ahead and pause the video, identify A, B, H, and K, and unpause in about a minute or two. We'll take 2. Okay, so A is -3, which means A gives us the amplitude. But amplitude always has to be positive. So the amplitude is, yes, the amplitude always has to be positive, because who remembers what the definition of amplitude is?
Oh, yeah, this is from the radius. Oh, yeah.
Distance, yeah, it's a radius, so it has to be positive. The amplitude is 3. What does the negative represent? Yes. Okay, then we know that B is 1/2, which indicates that the period is 2 pi over 1/2, which means 2 pi times 2 over 1, right? Nothing divides out. So the period is 4 pi. So when we're doing our graph, we're going to count by a fourth of that. So we're going to count by 4 pi over 4, which is pi. All right, the next thing we identified is h. H is pi over 2, which means we have a phase shift right pi over 2 units. And plus 1, k is 1, which means our midline is at where?
K equals
Y equals 1. Good. Okay, so when we draw our XY table, we start counting our x's at pi over 2. We should have written that in. Start counting at x equals pi over 2, which is h, right? So we always start counting on our table at h, and we're going to count by h plus a fourth of the period, right? Because in the unit circle, all of the important things happen at the quarters, right? The 0, then up to pi over 2, then pi, then 3 pi over 2, then 2 pi, right? That's 5 values. Start, go by quarters. Take the period, divide it by 4. That's your interval. So if we're starting at pi over 2 and we're counting by pi, we start at pi over 2. The next interval is 3 pi over 2. The next interval is 5 pi over 2. And the next interval is 7 pi over 2. And are we at, nope, one more. The last interval we're going to do is 9 pi over 2. The parent function here is a sine graph, right? So sine functions, sine of theta is usually 0, 1, 0, -1, 0, right? Because sine function looks like that. So we start at 0, we go up to the maximum, midline, minimum, midline, right? So now we are going to adjust our sine function to our equation, which is y equals the negative 3 times the sine of 1/2 x minus pi over 4 all plus 1, right? So each of our y values of our parent function are going to get multiplied by a, and then we're going to add k. So 0 times negative 3 is 0 plus 1 is 1. And we always check that first point to make sure that it works. Back in the original function. So y equals negative 3 sine of 1/2 times whatever x is, which is pi over 2, minus pi over 4, all plus 1. So if I put in where I'm starting at pi over 2, pi over 2 times 1/2 is pi over 4, minus pi over 4 is 0. The sine of 0 is 0 times negative 3 is 0 plus 1 is 1. Awesome. All right, go ahead and pause the video, find the other points, take a minute. Okay, so you had to pick the quiet time, huh?
I can't stop it. It's natural.
So we start at the midline, and we're going to go up by an amplitude of 3, but that 3 has been reflected across the x-axis. So we're going to do 1, right? Our parent function's at 1 times negative 3 is negative 3 plus 1, negative 2. You can also go from the midline, and we know since we're reflected, we're going to go down first. So 1 minus 3 is negative 2, right? Then plus 3 to get back up, right, would go back to 1, which makes sense because we're going back to our midline. And algebraically, 0 times negative 3, which is a, plus 1 is going to be 1. Negative 1 times negative 3 is 3, plus 1 is 4. Also, if we're at the midline, we're going to go up 3 and then back down to the midline of 1, which algebraically 0 times negative 3 is 0, plus 1 is 1. Those are our points. Go ahead and pause the video for 2 minutes and try to graph, and we'll be back. Okay, so we look at all of our x values, which are positive, and all of our y values, which we have negative 2 up to 4. So we want to make sure we leave room on our graph to do that. So here's our y-axis. And we want to at least make sure we have enough room. So if that's negative 1, negative 2, 1, 2, 3, 4, 5, right? Then we're going to count pi halves. So 1 pi half, this is pi, 2, 1, 2, 3 pi halves, 4 pi halves, 3 pi, 4 pi, 5 pi. And so draw your midline, which is at 1. Y equals 1. And then graph your function. So pi over 2, 1, which is your midline, that makes sense. 3 pi over 2, negative 2. 5 pi over 2, 1. 7 pi over 2, 4. 9 pi over 2, 1. So your minimum should be 1, 2, 3 spaces away from your midline. Your maximum should be 1, 2, 3 spaces away from your midline, and that's true. You don't have to continue the xy table if you want to continue the function. You just want to make sure that you're going in the same pattern, right? So it would go up and then down, and then we would go back to the midline, right? Or if you wanted to go backwards, we could go to here also. So your function, if you draw curves at the minimum and maximum, it gives you a nice rounded function. So we're going to go down and up and down and up. Make sure you draw arrows because it's going to continue forever. And there's your function. Okay, we're going to do one more example, or one more, we're going to talk about trig identities. So we're going to watch that one next.